Okay, we've started now. So what we're going to be doing in this session is we're going to go through the solutions to the assessment task that we just did. This will also serve as the video solutions for this exact task. I'll be scanning my solutions as well and uploading and all that stuff as well, but this will be the video component to it. So, question 1, and in this video I don't have the questions already labelled up, so you kind of need to follow along, so that'll be with it, but whatever. So, question 1, we need to evaluate log 5 in 3 decimal places. So I think almost all people got this completely right, or at least the basic concept. The only thing that was really mistaken here, when it says 3 decimal places, it generally means do it to 3 decimal places. Not 3 things, or 2 decimal places or anything like that. So here, we'll just say that ln 8 over ln 5, and that equals, okay, my solution here, 1.292. Alright, so that question's in there, even though it is very easy. When it's the first question of the paper, it should be easy. But the reason why I put that question in there is the HSC always starts off with that. The first question of question 11 is always just like an evaluation of some decimal places or CPs or something. Read the question carefully, make sure you're doing what you need to do. Question 2 is saying we need to differentiate the following. So we need to differentiate y equals, was it x over ln x? No, ln x over x squared. So what we're going to do here is, fortunately nobody did this. Fortunately nobody did like, oh well, you cancel like x's or something. Basically everyone went ahead and did quotient, okay, which is what we need to do. So we say that u equals ln x, so u dash equals 1 over x, v equals x squared, so v dash equals 2x. So that's 1 mark to start us off with that. Oh, I forgot to do the whole thing. Basically, so in this mark, the question is 2 marks, so 1 mark is setting up the quotient rule and doing the differentiation, so u dash and v dash. That's 1 mark. And then, so the other mark is going to be putting it into the question rule. So we got y dash equals u dash v. So it's 1 over x times x minus 2x ln x over v squared. So that's so that should be x squared. So v squared, so that's x squared squared, so x to the power 4. Is that ln x? Yeah, 2x ln x. And then, so what we can do from there is simplify a little bit. So first of all, 1 over x times x squared, well, that can be written as x squared over x. So the x is cancelled out, so that's just x. So that's x minus 2x ln x over x to the power 4. And if we wanted to, we could simplify that a little bit further. We all have x's, so we can cancel out that x, and one of those x's, leaving me with 1 minus 2 ln x over x cubed. You can't really do so much else to that. Okay? But basically, if you need the mark, really getting to there is fine because you differentiate at that point. It's always good to simplify, you should be doing so. But, you know, if you're answering the question, well, we've answered the question at that point, you don't really need to go any further. Of course, unless it says to show you that the derivative is low. Right? Yep.
You don't have to do that. Let's get rid of the half. You just understood how
What half?
1 over x times x.
So 1 over x times x squared, that's saying x squared over x. Alright? And then you can check that one. X is equal to x. Okay. That's not half. No.
That's true.
Yeah. Alright? Going to question 3. So what it's asking me to do is to integrate x over x squared minus 3. Yes, this question was done really well, which is good to see. Basically, everyone realized, oh, this is one of those things where I'm integrating a big fraction. So I want to make the numerator the derivative of the denominator. So what's the derivative of the denominator? 2x. Alright, so it's good to see that lots of people wrote to the side 2x. Some people even said 2x equals goal or something like that, which is good. But basically, that's what we're kind of guiding towards, okay? We want our numerator to be 2x. So what do I need to do to my integral? Well, not the half thing. Yeah, 2 over 2. Yeah. So we're going to do 2 over 2 times x squared minus 3. And so now what we want to do is we want to bring that 2 on the top over, but we're going to leave the bottom as it is. We don't want to change the bottom. What we can do is, so we're going to have half times 2x over x squared minus 3 dx. And remember what we can do is we're going to take that half, bring it outside, which will leave me, now what I can do is I can now integrate that, because now the denominator, the derivative of the denominator is the numerator. So we're just going to do half ln x squared minus 3 plus c.
Why? Like, I memorized this, I don't know why.
Okay, so when the numerator is the derivative of the denominator, so in this case it is, 2x is the derivative of x squared minus 3, at that point, when you're integrating it, you can make it ln of the bottom.
Wait, you differentiate the bottom and take the top.
So on the formula sheet it looks like this. If it says, so what we're saying here is, if there's a function on the bottom, and the numerator is the derivative of that function, that equals ln of the thing at the bottom.
Yeah, I get that. Where do you get 2 from those?
The 2, that 2. Because the idea is right now, what's the derivative of the bottom? 2x. Problem is that's only x on the top, so we're going to have to change something. So far so good. So what I did is I times by 2 over 2, which I haven't changed anything here. I'm timesing it by 2 over 2, which is 1. I'm timesing it by 1. And then what I can do then is I took the 2 over, but I kept it half out. It's kind of working as a counterbalance, because if I'm multiplying the top by 2, I need to multiply the bottom by 2 as well to keep it equal. And then go from there.
So you're forcing it?
Yeah, I'm forcing it in. Yeah, so because the idea is I'm realizing, okay, I'm probably going to get a lid here, but I've only got one issue here. What can I do to change it? Now that I've done that change, but using that half as kind of like a counterbalance, now it's a lid thing. But don't forget the plus c. I think 1 or 2 people also mark instead of plus c.
Was that a mark?
Well, it wasn't a mark for the plus c, although if you did write plus c, you would lose a mark. Yeah. So if we're going to the beats of this question, basically it was a mark for having a half at the front, and then the other mark was ln x squared minus 3 plus c. Yeah. That's a good question. 4. So here we have 4 to ln, was it x minus 1 dx. And what the question is asking us to do is Simpson's rule with 3 function values. So how many applications is that?
2. I got it right.
So 3 function values, when we do the fingers thing, so Simpson's rule uses 2 spaces, so this is 1 application. So we need to do FML, first, middle, last. And this is where I see lots of people still make mistakes. Like, the formula is a really ugly way of looking at it. It only makes people make mistakes. Maybe we don't do differentiating or anything. Lots of people try integrating that. You can't integrate that. We haven't learned how to integrate ln functions. Okay? We can integrate things to make them ln functions, but we can't actually integrate ln functions. This is why it's asking you to do it with Simpsons, because you can't do it otherwise. So here, our first, if we just do a table of values, so our table of values, our first point is 2, and our last point is 4. So what's in between? Okay. So this is our first, that's our middle, that's our last. Again, 3 function values. That's 2, that's 4, that's 3. Okay, first, middle, last. And then so, if we make x equal 2, this is the other thing, we're not summing in 2, 3, and 4, we're summing x into that, so 2, 3, 4 into that to get the y value, the function value. So, if x equals 2, what's 2 minus 1, so lim 1, which equals 0. If I make x equal 3, 3 minus 1 is 2, so it's lim 2. And if I make x equal 4, it's lim 3. That's what we're going to sub in. Don't do any of the, don't try to think of the a plus b over 2. I think that makes it hold it. Okay?
Just add these 3 things up.
Well, no, we're not going to add those 3 things. Those are the 3 things we're going to be putting into the formula. So this is approximately equal to, first of all, what's the difference between 4 and 2? What's the difference between 4 and 2? 2. So it's 2. The difference over 6 is always over 6. Bracket, the first thing. So not 2, don't sub in 2 here. Sub in 0 or lim 1. So 0 plus 4 lots of the middle one. So what was our middle value? Lim 2. Alright? Don't sub in 3 or don't sub in 2 plus 4 over 2. It's not saying 4 times 3. It's 4 times lim 2. Alright? And then lastly, plus lim 3. Alright? First, middle, last. And that middle one is times by 4. Okay? Use the y values. Don't use the x values. Alright? And then going from there, we'll just simplify it a little bit. So this equals 1 over 3, 4 lim 2, 4 lim 2, 4 lim 2 plus lim 3. And then we can rewrite this if we expanded it. 4 over 3 lim 2 plus 1 over 3 lim 3 as well. Well, I mean, you're right. I probably should write squigglies, but because I wrote a squiggly at the start, I'm saying that this squiggly thing is equal to this. I'm still saying it's approximately equal to, but you're right. I probably should use squigglies. Yeah. As long as you have one squiggly at the start of your Simpson rule, because this bit here is exactly equal to that, but we're saying this is approximately equal to this equation. Okay?
So, when you simplify the rule, expand it?
Yeah. No. I mean, basically, again, the question's asking you to integrate or find an approximation using Simpson's rule. You've done that here. So that's a mark. And then the other mark is really, this is 2 marks, right? Yeah, so like the 2 marks would really just mean, are you first of all finding that middle value? Okay, so 3. But then also like using the formula correctly, and then also using the function values. Right?
So if I stop there, like right the top one.
Yeah. I mean, again, it's one of these things where I'm 90% sure that yeah, you would. Although to leave it like that would be ugly, and it's just not the right thing to do. It's kind of like leaving your answer. It's like leaving your answer 6 over 2. Why?
Yeah,
Take it?
Right.
Time is ticking, sir, you know?
Yeah,
Time
he's
is
got a
money,
point.
you know?
He's actually got
I
a
lost
point.
the whole
I
thing.
mean, you're right. Okay, you're right. If you're not totally confident in your expansions or anything, just leave it there.
Yeah, that's why I
I
didn't
didn't
expect
use rule for
that.
this. I don't know. Use all of those lines. That's the thing.
Oh, okay.
I'd use all of those
Right.
lines. I lost
Question 5, and I'm sure lots of people want to go through this one. Alright? So we have.
It looks 2 minus 1. You do another way.
Alright. So this is a question that lots of people got tripped up on, so we'll spend a bit of time going this one. So we're told we need to solve this exponential equation, and by itself is absolutely disgusting. Alright? But we're told, we're given the hint, we should let u equal e to the power of x. So once we've done that, well, e to the power of 2x is e to the power of x squared. And e to the power of x is u. So we have u squared. Plus 3u minus 10 equals 0. You don't get a mark for just doing that. Now you got to do. This is a what type of equation is this? A quadratic equation. And how do we solve quadratic equations? You don't move the 10 to the other side and start doing that. Right? So what two numbers can multiply and be negative? Yep, sorry, was that line?
When you say solve, what does that mean? Like,
Solve means find the value of x and makes it equal 0.
I didn't expect that.
Like if I had
Because like
x.
we didn't do this, like you just stuck it in there.
I'm bothered with this.
Really? Okay. I feel like it's just so random.
Maybe not a question that bends itself into a quadratic equation.
I was
but
gonna
yeah,
start
I'll ask
differentiating.
something
I was gonna start differentiating. I was like, well, that doesn't look right.
Like,
It's called what? When did we do this in this chapter?
No, but that's the point. That differentiates you from the band 6s.
Alright, we did it.
okay. I mean, I've got to ask some challenge questions as well. So now we've perfect that. So u equals what?
U equals negative 5.
Fine. So that's 1 mark there. 1 mark is finding the two values for u, but we don't care what u is. We care what e to the power of x, or we care what x is. So therefore, e to the power of x equals negative 5, and e to the power of x equals 2. Now, we never got actually find what x is.
Sum it in, find out.
So how do you?
We're not trial and error. That's an exponential thing that we can't solve that by itself. So how do you solve an exponential equation you can't solve? Exponential form. So we got log base e negative 5. So then negative 5. No, negative 5. Equals x.
Yeah, then negative 5.
And then 2 equals x. So there's my two solutions. Except, which one doesn't exist?
What?
That first one. E to the power of x can never be a negative. If you put into your calculator then negative 5, it will give you a math error. So therefore, x then 2 is the only solution.
How come that one's a lin and that one's a log?
That's then.
It's the math.
No, as in it's the same thing.
They're
We just
the same.
It's not the same thing.
log base e.
I was writing
Log
it as
base
log
e.
base e. Yeah.
Log base e.
Log e negative 5 is the same as log.
Okay, so if you write log e 2, it would be. But then why did you?
No, log e. Yeah, log e2 would be fine.
So it would be the same.
Yeah. So what we're saying here is the two solutions either e to the power of x is equal to negative 5 or e to the power of x is equal to 2. There are no solutions here because e to the power of x can never equal 0 and it's never negative.
So why'd you just out of nowhere bring in log and do like that's nothing.
What's the opposite?
Like alright, what you were doing is you were finding like you just went into you were doing the quadratic whatever and then you found out what u was. How did you get to there?
Okay, so we don't care what u is. See, the question's
I mean
saying.
x, whatever.
Yeah. So okay, so we found u equal to negative 5 and 2. We don't care what u is. We reverted that substitution, so now we have e to the power of x equals that, e to the power of x equals that. Now these are two things that we need to find. So what we're asking is e to the power of what equals 2, e to the power of what equals negative 5. Now solving that by itself will take forever. It would just be a bunch of guess and check. And how do you solve exponential equations? You change the form. So changing the form, do that base becomes the base, power becomes the subject, blah blah blah. So we get x as the subject now. So x equals then 2, and x equals then negative 5, except then negative 5 will give you math error. We can't do more than a negative number. Alright? So that's that. Going to question 6. Question 6a. So first of all, rewrite the function y equals e to the power of x so that x is the subject. You don't just sub in. Rewrite the function y equals e to the power of x. This is just one line. This is just one line. Base becomes the base. Now it becomes 13. Now look, x is the subject. Done. You make x a subject, x is by itself.
How did you do that? I think you did my mind.
Yeah, I wasn't confident when I
Oh, wait.
That it?
That's it.
Oh, well, now that's something else.
Because x is now a subject. Alright, next.
Oh, you moved to the other side.
Find the y-intercept of the function y equals e to the power x. How do you find y-intercept?
Make y x equals 0.
If x equals 0, y equals e to the power of 0 equals 1. So therefore, 0,1.
Okay, yeah, so I didn't do 0.
Yeah. I mean, you should write that, but I don't.
It didn't say what's the.
Well, if it's asking you for a y-intercept, you need to ask what it was. So find the y-intercept.
Yeah, but it says y intercept. It doesn't say find the intercept. That means y intercept and y.
There's two different intercepts, aren't there? There's x-intercept and y-intercept. I can't just say find the intercept. Because I haven't specified which intercept. I could say find the intercept, and now I'm asking you to find both of them. But in fact, there are no x-intercepts of y because each have x. So lastly, hence write down a definite integral function, definite integral whose value is the volume of the solid. So what we're saying here is it's being rotated around the thing. So here we're going to say that volume, the basic volume, first of all, guys. So V equals that. So this is generally what it's going to be. So that's in general what it's going to be. That's not the answer. But when we're rotating something around the y-axis, okay, we need to find x squared. We have pi, and our b and a are not going to be the x-intercepts, the x boundary points. We're looking for the y boundary points. So if you did 1 and lim 5 or 0 and lim 5, you're looking at the x-intercept. Okay? We're rotating around the y. So, from here, first of all, if it's pi, we know, what's that one down there? We just found it?
1.
It's not 0. 1. We just found that apart too.
It's above 0.
What was x when it says it's subject? It's lim 5, lim y. So x squared is just lim y squared.
Well, how do you do the
Why is it in y squared?
Because remember in part 1 we said that x equals lim y. So, but we need x squared because we're rotating around the y-axis. Because we're rotating around the y-axis, we need x squared. This is dy, and the other thing we need to find as well is what's that boundary point up there? 5. It's 5. So click it as well. Yeah. So So what we're going to do, if we're saying that that point there is meeting e to the power of x at lim 5, basically what it's saying is we're going to make x equal lim 5 in that original function. So if we have y equals e to the power of lim 5, does everyone see what I've done there? Does everyone see why I'm making x equal lim 5? Alright, so looking at that line.
Yeah, I don't get what you mean.
So looking at the line. It's being bound between x equals lim 5. It says that in the question, it says that in the diagram. So x equals lim 5. But remember, I'm not rotating around that way. I'm rotating around that way, meaning I need to find where that is. So the way that I can find what that value is, we're saying if x equals lim 5, then that y value would be, like we're trying to find what that point is, it would be horizontal. So if we make x equal lim 5, and then we sub that in e to the power of lim 5, put that in calculator or whatever. Yeah. So, and 1 over is 5. So therefore, we're rotating between that's 1 and that's 5.
I don't remember what I did that.
Yeah, I don't know how you got.
So, I mean,
Yeah, but it's going to be X on so you're supposed to keep X on one side.
yeah, but because you would be right if you were rotating it this way. But because we're rotating it this way now, I need to find what that point is. Again, the boundary limits.
Well, what made you from X is not in 5?
Because I didn't know where that other line was. I just knew that that was some line, and that line was intercepting y equals ex when x equals 2 and 5.
I just don't want to get it, but like, you couldn't have question.
Yeah.
How does it work done?
We have done a
I feel
couple.
like you just, like, it just looks like you just use this box, like this. You just, like, oh,
Yeah. So like that's what lots of people did basically exactly that, except they didn't like it. Alright? You need to realize that we're not rotating around. So most people did 0 then 5. That'd be right if we're rotating around x axis, but we're rotating around y axis. Maybe we need to think of the y values as opposed to the x values. Alright? I mean, again, that is one of the harder questions. I mean, there's 1 mark for there's 1 mark for doing that. There's 1 mark for getting that bit. Alright? Alright, let's go to question 7. So now the trick.
oh, wait, so can we go back?
Yeah, well, I don't know.
That's the last bit?
So that's not it.
That's it. Because you don't need, it said really clearly, do not evaluate.
Oh, yeah.
What if someone did?
Nope.
So what was the most annoying thing you got like from this?
When I say around for 3 decimal places, I
Oh
mean
my
it.
god!
No, really.
I
did that as well.
Yeah.
I did that.
How the fuck did you get that wrong?
Listen, I was in a rush. I was literally so scared. I was
In my
literally
head,
Yeah,
I
so
was
first
so
question
scared.
you're expecting something.
So, in my head, I thought
No, you know what
I
I
mean
wrote?
like this x equals log e x.
This is how dumb I am. I wrote 3 decimal places and I put 2 decimal places. I wrote 3
Look this look.
And I wish I could give you that mark because I know you clearly know what's going on.
I
But
literally wrote
you need to prove to, like the HSC mark is to actually know who you are and what you know what 3 decimal places.
Well, we perfectionists.
Question 7. Find the equation of the normal blah 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 blah. So, first thing, the key word is like there's 3 marks, 3 beats. So, 1 mark is going to be the differentiate. 1 mark is going to be find the gradient of the normal, and 1 mark is find the equation. Alright? So, start us off. Yeah, like so the function was y equals sine 2x. It's really good to see that basically everyone differentiated this correctly first of all. So y dash equals the power 2 cos our respects. There you go. Okay?
What was the negative part?
Yeah, you have to give integration. 3 marks. So you would
How
have
did I get anything?
That's a lot of marks.
know when you're done. So the first thing you need to do is find the gradient of the tangent. Am I going to do that? Make x equal pi to 6. So if x equals pi to 6, then y dash equals 2 cos 2 pi to 6. So 2 pi to 6 is pi to 3. Alright? Cos pi to 3, cos 60. 1 over 2. So when I do 2 times 1 over 2, that equals 1. Because this is 2 times x. So if x equals, so 2 pi over 6. So 2 pi over 6, yeah, so 2 times 7. Yeah, pi to 6 is 30 degrees. So times by 2, so 60 degrees. And so cos 60 is a half. 2 times a half is 1. That's the gradient of the tangent. So therefore the gradient of the normal equals negative 1 over 1. Negative 1. So that's 1 mark there. So,
I thought I did it wrong because negative 1 seemed like too much of a difference. So I was like,
It's negative one.
yeah.
I think it's so easy. You'll never do negative 1. This is going wrong anyway.
I just got one.
I don't get 1. So what's cos 60? What's 2 times 1, 2?
1.
Alright, and then, but that's the gradient of the tangent, so the gradient of the normal is negative 1. The other thing we need, guys, before we start putting into x minus, y minus y1, x minus x1, all that kind of stuff, we also need the y coordinate. So if x equals 5, 6 again, y equals sine pi over 3, or we can do pi over 6, alright? So what's sine pi over 3? So sine 60? You're right, we're correct. We got root 3 over 2. So now we have my y value, that's y1, that's the gradient, and obviously our x1 is 5, 6. So now we're going to slip it into that point gradient. So therefore, we have y equals, y minus root 3 over 2 equals negative 1 x minus 5 over 6. So yeah, I mean, I already feel
Is
paper,
that
but
y
to give you
equals 1?
a
Yeah,
master.
it's called consistent marking. Like, you do it all correct, but I think it's
Yeah, but
it's
like,
all correct.
if you do root 3 divided by 2, 0.9, you got 0.09. I was just like, can't do it. Well, I gave you one somewhere else, but yeah.
I don't agree. Is it four?
Oh.
So, is that y equals 1 or y1?
Huh?
That one.
That's y.
No, not that. The one on top. No, up.
Oh yeah, that's y1. So that's the y coordinate that we're putting into this formula.
Oh.
You know how it's y minus y1 equals tan x minus x1. So x1 was the point they gave us, y1 is the point we found, and was a gradient. And then we could do all the expandy stuff, so we might as well just quickly go through that.
So, just a question.
But I will.
You're finding the gradient of the normal.
Yep.
Let's say you find and it says that it's find the equation of the normal.
Yep.
Let's say you find the equation by looking tangent, and then when you're done, you just turn everything negative.
That won't work. There's only some things which turn negative. Only the x's will turn negative, but also because you flipped it. Because remember the tangent and normal you flip it and negate it. You don't just negate it, you just flip it as well. So it actually makes quite a bit of a change. Alright. Unless you just realize, like say I found it to be 1 over 4 earlier, but then when you substitute you knew to do negative 4, that would be fine. But you might as well just say, well if that's 1 over 4, that means my normal is negative 4. You might as well help yourself. And the half. We'll quickly just do a bit of expansion here. So we have y minus root 3 over 2 equals negative x plus 5 over 6.
So when
Hold on, let me just. You don't have to, but you should. Once again, let's multiply everything by 6 to get rid of fractions. And you have 6y minus 3 root 3.
the longest possible way. It's a short way. Get the mics clean, you need to get out. He's acting like it's 10 hours exam.
Doesn't do it.
He's like, I don't like to do it that way.
Doesn't do it.
Said you can do it that way.
This is what you could get to. Maybe the question would say show that the equation is that.
Good.
Well,
good. Might.
Then I'll write extra marks, please. No, then wouldn't the chance of question marks? We'll make it longer.
Yeah, well, I mean, yeah. So if the question, there might have been 4 marks if it said show that it equals this. But I would have kept still as 3. I mean, there's not too much work to go from there to that.
It is. It's like what?
Yeah, but because you know the final destination that you can work towards.
If they didn't, like, if it was like this question, and we continued, and I got it wrong, would I get it wrong? If I continued and I got this one wrong,
You probably should. Did I?
No. I'm saying if I didn't do that, but like
Good, yes, you can.
if I continued and like I did it wrong there.
Because you're showing a lack of understanding. So even though it's not really related to the question. Yeah.
Exactly what I'm saying.
Yeah.
But yeah, you're right. There's that risk of
Like you
continuing.
might screw up.
Yeah. So look,
When do you know when to stop?
if you left it, I mean, when do you know when to stop? When you've answered the question. Here, technically, I've answered the question at that point. You can
That's
leave.
where I
But
stop.
no, because you don't want to put in brackets unless someone moves into it.
Yeah.
And then like I end up having to simplify it.
I mean, the other answer is, and again, it's the answer that students don't like. You do so many questions, you eventually learn when you should stop, when you don't stop. So, for instance, when you do big, ugly quotient rule questions, you're not going to expand those brackets. It's going to be a pain in the butt. This one, that's not too much of a pain in the butt. I mean, like, look, negative x, they change the sign. You multiply by 6 to get rid of 1. It's not huge, guys. So, like, do it.
Do it.
No, let's do it. So, question 8. So we want to sketch the curve, blah, blah, blah. So y equals 2 minus cos 2x. So, the key thing here is, I'm still going to look into it. The key thing here is, quite a few people thought, oh yeah, no, I'll do that instead. Okay? You can't just decide to change the order of things. It is written like that for a reason. The question was written like that because, I want to make sure that you could understand what that's saying. This could also be written as negative cos 2x plus 2, and now lots of people can recognize that. So, look at this. What does the negative do? What does the 2x do? Yeah, it squeezes it. Yeah, it changes it here from. Yes, exactly. And what does the plus 2 at the end do? Shifts it up. Combine those three things together. So here it might help. The range. What's the range? Yeah, so because normally it's between 1 and negative 1, but if we're shifting it up to, now it's between 1 and 3. And the period equals 5. Other than that, you just know that it's shifted up, flipped, squished. And then so if we know it's between 3 and 1, so remember that's 2 pi, that's pi, that's pi over 2, that's 3 pi over 2.
So it just would pencil.
You can do it in pencil. What does it say? Does it say sketches can be made in pencil?
I thought it had to like be drawn.
Nah. So use it, do it lightly in pencil, but then do it in pen or something like that.
You have to in pen.
And that's it. Yeah. So, so that's pi over 2, but because it's been squished, I also need the anchor points in between as well. So, where does cos normally start? But because, so we should start 2, so now it needs to start at 3. So we're flipping it, so now it's starting at negative 1. So there, 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 there. Now the other thing is just to make sure you need to be clear with the shapes of your graphs as well. Remember, it works like that. So I saw 1 or 2 people doing this kind of thing. It doesn't, like, if you were to think about it, it doesn't kind of like point up at this. These are all stationary points at the end of the day.
So, okay, you know where it changes the gravity?
Mm-hmm.
See, I'm normally,
Question as well.
yeah. Is it always 1 above the middle? Or middle?
It's always going to be halfway between the two axes. And yeah, so it's 3 marks. That's because there's 3 things that are being done to the normal cos graph. It's being squished, 1 mark. It's being shifted, 1 mark. If it's being flipped, 1 mark. Question 9. So question 9, find the size of the angle subtended between the two radii to find this sector. Fairly simple. If we know that 5 pi equals 6 theta, means theta equals 5 pi over 6. And I was going a bit insane seeing the amount of people writing 150 degrees. So it is radians. You're not wrong, so that's totally fine. I said it was 5 pi over 6 radians. The reason why I suggest you keep it as 150 is I'm pretty sure inch down. If we write 150, you're going to... Huh?
You should have just said no.
No, I'm not allowed to do
But
that.
it's an angle, sir. Angle's supposed to be degrees.
So you should just told me
There's
to
two
shut
ways,
up.
there are two ways. There are two ways of measuring angles: radians and degrees.
I picked them
Seeing that we just did a whole unit on radians.
Yeah, but I feel like if we did it in radians, it would have been like.
Yeah, I feel like I did it wrong.
Degrees are in degrees.
150 degrees is correct. You wrote 150 degrees. Nothing wrong with it.
You scribbled it off, sorry.
I know people don't like it, so it's correct. Okay. Hence, calculate the exact area of the sector AOB. So here, area equals half times the radius squared times 5 pi over 6. And this is where the issue comes. Whereas if you left as 150, but if you write that the half times 36 times 150, you now got a massive number. Okay? Yes. Which doesn't. It's definitely wrong. Because that was 2,700 centimeters squared. Think about how large that is. Like, think about your sector here. Like, it's probably about that big. Like, if your radii are 6 centimeters, it's something like that big. Okay? Does that look like 2,700 centimeters squared?
No. In my
Okay.
mind, it's not
You
to
must be
scale.
here, aren't you?
Well, I didn't have enough
It's
time
not
to go
to
back
scale,
to
sir.
it.
Okay, you're right. It's not to scale. You're right. But if you were to, how is it massive? Because you know what the measurements are.
It might be 6 centimeters.
So,
Okay,
when I look at see, I'm like,
Maybe
this wrong.
only-
9 centimeter difference wrong. But I didn't have enough time. I needed to do question 10.
So anyway, when you go from here, this simplifies to be 15 pi square, centimeters squared, I believe. Just sure. So this equals 15 pi centimeters squared. The other thing is, I think a couple of people lost marks here. The question says find the exact area. Okay? Don't put in decimals. You will lose marks if you
No,
do
but
that.
I didn't put it just I got 42 units 36 left.
Because you're right. Probably. No, you got marks. You got marks. But so that's part C. Part C, putting in a decimals is fine because in the question it never said find the exact area of the segment, which we'll go into in a second. So part B or I, whatever. Yeah. Part B, it says explicitly find the exact area. Part C, it never said the word exact. So therefore you can do decimals. Don't like it, but you can. Alright? The general rule of thumb here, guys, unless the question specifically says 2 decimal places or something, don't do it. Just don't do it. It will not help you. So lastly, so quite a few people just use the formula, let me know. So the area of the segment is equal to half r squared theta minus sine theta. So that's half. So that's r squared is 36. So 18 times 5 pi over 6 minus sine 5 pi over 6, which is half. Which equals, well, 18 pi over 6, so it's 15 pi minus 9 degrees squared.
You put it to the calculator as.
You get like 13 point something or other.
No, take a sine 5 pi over 6. You get half.
Yeah.
And that top one's still right. So I don't continue to centimeters.
Yeah, that's fine.
It's fine.
Exactly, I'm trying at that point. What I've done in my solutions as well is if in the previous question you just found this, the area of the sector, I then kind of drew the line between A and B and found the area of that triangle, which is 9 centimeters, and there's 15 pi minus 9, which is essentially what that formula does. And then I just found the area of the sector, found the area of the triangle using that half AB sine thing. Gives me 9, 15 pi minus 9
gives you the answer as well.
So I was so close to not doing it. It's because the wording I don't know what it just kind of say.
Yeah, that was part of the question. No, that
I
was
didn't-
that
I
was part of the
don't
question.
do it.
I want to make sure that you understood it, everyone was you did it. I mean, so the chord ABs, you need to know what chord is. Drawn to produce. What does produce mean? A segment. What does segment mean? Chord arc. What does that mean? Area of the segment. Okay, so there's like lots of things going on there. I could have just said, here's the segment, find the area of it, but I wanted you to create yourself. Lastly, so 10A, even though it says I. So show that D, DS, log, blah, blah, blah. Basically that's saying if Y equals ln cos X, if Y equals ln cos X, we want to differentiate it. So how do you differentiate a ln? You differentiate what's inside and you put it on the bottom. And then you keep what's inside the bottom. You differentiate what's inside. So what's the derivative of cos x? Negative sine x. And so negative sine x over cos x equals negative tan x. Why are we integrating?
They can't integrate.
Oh yeah, cos becomes negative sine. Yep. So going into question 2, the shaded region in the diagram is bound between the blah 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 blah. And can I just point out that notice how they were always graphed in these questions? So what we want to do here is we want to find the area underneath y equals tan x. We want to find the area underneath y equals x between 0 and pi over 4, and then we subtract. So what we're going to start off with is this area equals, it's between pi and 4. Everyone see why it's between pi and 4? It's that line. 10x dx minus pi over 4, 0, x dx. That's one mark, just to set up what we're doing. Okay? Then going from there, we just did part A for a reason, right? Because we've never learned how to integrate tan x. We can do it, but it'll take a little bit of time. But we could do it, but we could differentiate tan x. The derivative of tan x is sec squared x, right? The amount of people that wrote sec squared x here is the issue, because I guess when I said the other day that nobody tried to differentiate when you're integrating, I think lots of people kind of learned to autopilot here. You saw tan x, and you go, oh, that goes to sec squared x. Only when you differentiate, right? We need to integrate tan x, which is something completely different. And we've never learned how to tan x. Exactly. We just did part A for a reason. Alright?
They're dodgy, they make it negative, so it tricks you.
You're right. So that means we are going to have to do something about that.
Just don't put it.
Well, okay, so...
Because if this tan has a negative, that means that one's negative.
Well, so the way that we do this... So... I want to... That tan x, I can't work with it yet, because in the previous question, it was negative tan x. So I'm going to somehow need to make this negative tan x. So this is still pi over 4, 0. So if I want to have negative tan x, for me to do that, I'm going to need to put a negative outside as well. It's kind of like counterbalancing. Remember how we did that 2 over 2 a couple of questions ago? It's the same concept. I'm kind of like timesing it by -1 over -1. So if I'm going to, because I want to eventually get a negative tan x, right? But for me to have that negative tan x, I'm going to need to have a -1 sitting out the front there as well.
Just assume you didn't do it. Just take it out.
We are just going to take it out eventually. We're nearly done this question. We will be. But if you need to go, go. But we'll be like soon.
So,
there's that -1. All right. What can we do with What can we do with coefficients in that? Let's bring it out. So now we have negative pi over 4, 0, negative tan x. dx minus, now from here on, I'm going to say that this is pi squared over 32. Alright? I'll talk about how I got that in a sec. Well, let's just talk about that for a second. What's that white shape? Triangle. How you find the area of triangle?
Oh no.
Half times base times height. So that's pi over 4. What's
What
pi over
triangle?
4? So half times pi over 4. So pi times pi is pi squared. 4 times 4 is 16 times by 2, so 32. You could have also done, so that's how you could do it, or, I mean, you could just do it the old way, which, well, let's just keep it as that, so pi over 4 is 0 to dx, still haven't integrated yet. What's the integral of negative 10x? What did you just differentiate? You just differentiated something to equal negative 10x. That means if I integrate negative 10x, it'll be it's one of those questions where we just did the previous thing for a reason. The integral of negative 10x is ln cos x. I don't know that. The only reason why I know that is because in the previous question it told me that. Okay? Minus, what's the integral of x? Half x squared. A couple of people forgot to put the half at the front. And because remember, you increase the power divided by that new power. Let me just finish the question. So go from here, we've got negative. So cos pi over 4 is 45. So then 1 over root 2 minus what's cos 0? What's cos 0? So we've got in 1. Minus, if I do pi squared, so pi over 4 squared is pi squared over 16.
Okay,
And then if we're dividing it by 2, so it's 1 over 2 times pi squared over 16, so pi squared over 32. If you say so. And then if we make 0, it's just minus 0. And then lastly, let's expand. So ln 1 on root 2. What's you could have finished that. What's ln 1? So ln 1 on root 2. Oh, sorry, minus ln 1. Minus ln 1 on root 2 minus pi squared over 32.
unit squared or cubed or squared.
Was this the last question?
Yeah. Well, I mean, the last question of street and the last question exponential, I think, would be equally as hard.
So why did you? Okay, you know how?
What was the other last question?
Yep.
I don't want to go.
Let's just do full screen it, and then we'll.
Substitution one.
And the substitution one. I'd say the last two of exponential, the last one street were probably the hardest.
Okay, you see how you change it to negative times y?
Because we just did a question in which we differentiated something that equaled negative 10, right?
Yeah.
So why not use it? I can't integrate 10x, but I can integrate negative 10x. To go back into what we just differentiated. That's why I need to get negative 10x. But to do that, I also needed, like if I do negative times a negative equals positive, then I haven't done it. So if I'm going to put that, make that negative 10x, I have to bring the negative at the front as well to do that counterbalance kind of thing. And then just do the whole thing. That's why I was going to go, I was able to go straight from negative 10x to ln cos x. There's no way I would know that unless I did part A. And even if you did do part A, it says shows that it equals this. So you can still use it, even if it's fine.
You take it off.
Sorry. What if you did lin sin x? Why would you did lin sin x over lin cos x? No, I did sin x over cos x.
Yeah, so okay, so you know how the question says or otherwise?
Oh, you turned it into lin.
Remember
Cos
in
x.
part 1 we just did this? Okay? So I've got 10x, I don't want 10x, I want negative 10x. So for me to make that negative 10x, I also need to put a negative at the front, the counterbalance kind of thing. I can't multiply this by negative. Okay, you get that. Sorry.
I was confused that why it become lin cos x, you just made it lin cos x.
Yeah,
you made it
from
backwards log e x.
Yeah, exactly.
Do you have to do that? Can't you just do sin x over cos x?
What? What?
Right,
Because when you integrate negative 10x, it equals that. 10 changes.
no, it doesn't tan x equals sin x over
Yeah, but not when you integrate it.
what? When you integrate it.
Integrate it. So the integral of negative 10x is ln cos x from that.
So sin x over cos x won't be the same. But
No.
doesn't ln cos x equal sin x over cos x? If you differentiate it?
When I differentiate, yes. Yeah, so I don't see where your issue is. I mean, are you saying, could I have done... Are you saying that?
No, I'm saying tan x will equal sin x over cos x.
Before.
Yeah.
Oh, then when you...
But when you integrate it, it
because
becomes
they're
that.
equal the same. We
Yeah.
try to show equal.
Yeah, but when you integrate it, it becomes that.
Part A, I got confused.
Yeah.
Am I too tired?
Yes.
Isn't that the differentiated version?
That's the original. So when I differentiate
Oh,
it, it's negative sin x over cos x, which is negative 10. And that was the question I was asked to see.
Yeah, and then when you integrate it,
Yeah,
that
I'm
would be the differentiated version.